Now this is an equilibrium question where we're being told of the various changes that can happen in equilibrium, adding or removing heat, increasing the temperature, decreasing the temperature, removing or adding one of the reactants or products, changing in pressure. And we've been given a reaction and we've been shown on the graph some responses, and it's up to us to interpret those responses in terms of equilibrium. Now all I've done here is just write out, on the left we've got the reactants and the right on the products, and it just, for me, would simplify that. So at position W, what happens? Well, we get a decrease in CO, we get an increase in H2O here, and we get an increase in CH4, and with H2 we get an initial increase and then it decreases. So that initial increase here can only be due to one, that we've added some H2, and when we add H2, obviously we increase this, it's going to shift to the left hand side as it responds to the stress of the change, and that's going to mean we're going to get more H2O CH4. We've got a decrease in CO, but obviously the amount of H2, even though it goes to decrease, it's not going to go to less than what it was before. And basically we'd go through explaining that with reference to the equilibrium. Now we're going to look at position Y. Now at position Y, again we have a increase and the amount of H2O, so that increases, and CH4 we also get an increase. And in fact, when we look at all these graphs, we notice one thing. The increase, for instance, in H2O, CH4, H2, CO2, they all increase. It's almost as if we're getting an addition of reactants and products across the board all at once. And how can a concentration of gases all suddenly appear to increase and then change? Now that can only happen if we get a sudden decrease in volume. So we get a decrease in volume, that means really we're increasing the pressure, but if we decrease the volume we're increasing the concentrations. So that's why initially they seem to all increase, but then we get a response from the equilibrium. For instance, the H2 starts to go down, and that would be because if we get an increase in pressure, it's going to want to shift to that side. So the H2O increases and it stays increased in this one. The CH4, which is down here, increases and stays increased. And to the other two, we get that initial increase because of that decrease in volume, and then it goes down as the equilibrium shifts to the other side. And we'll just explain that through that way. Okay, and that's the second part. Now, at position X, which I kind of skipped over, well, there's no change here, no change here, no change here. So something apparently has happened which has caused no change at all. So maybe a catalyst was added, and it maybe sped up the rate of forward and reverse reaction, but it wouldn't have changed the overall amount of reactants or products, so there'd be no change there. Possibly we added a gas that's unreactive, an inert gas, and that would have had no effect on it as well. So you just need to discuss those issues for X. Now at position Z, these changes are gradual, so there's no sudden change here, but with H2O it goes down, and with CH4 it also goes down, with CO it goes up, and with H2 it goes up. And so what's actually happening here? Now obviously, just in exam thinking mode, if we've looked at changing pressure and volume, and we've looked at changing reactants and products, we should now consider maybe this is an endothermic exothermic question to do with changing temperature. Now obviously if we've got an increased amount of CO and H2, we know that the equilibrium has shifted to that side. And we're also told that this is an endothermic reaction. Now if it's shifting in that direction, and we know that this is the endothermic direction, that's a cooling kind of effect, we know that we must be increasing the temperature, because if we increase the temperature, it's going to shift to the side that favours the endothermic direction, and the endothermic direction is to the right, it favours the products. So we'd be talking about that in our answer, and that's that question answered.